Here's a fact almost nobody believes the first time they hear it. If all the ice in Antarctica melted, sea level right along its coast wouldn't rise. It would drop. Not by centimeters, by tens of meters lower than it is today. That's not a mistake, and it's not a joke. It's the laws of gravity completely flipping our intuition about what happens when all the ice on the planet disappears. Now, picture this. All that water that didn't stay near Antarctica has to go somewhere. And it does. Straight into New York, London, Shanghai, and hundreds of other cities where hundreds of millions of people live. Today, we're breaking down what would actually happen to the world map if every last bit of ice on Earth melted. Spoiler, the result isn't at all what the internet usually shows you.
Hey! Today, it's a hypothetical, but scientifically grounded scenario. What happens to the planet if all the ice, glaciers, Greenland, Antarctica, melts completely? Here's what's coming. Exactly how many meters get added to sea level? And it's way more than a couple. A strange gravitational paradox that means the water won't rise evenly everywhere. A real disaster caught on camera. An ice shelf the size of a small country fell apart in 35 days. And what the new world map would actually look like. Which cities vanish and which land appears out of nowhere. Let's start with the numbers.
First thing to understand, all the ice on the planet won't melt in a year, or even in a century. Under the most alarming models, that would take at minimum several thousand years. But today, we're not talking about the timeline. We're talking about the end result, once the whole process is finished. And there's far more ice on this planet than most people think. Over 99% of all Earth's freshwater ice is concentrated in exactly two places, the Antarctic ice sheet and the Greenland ice sheet. Every other glacier on the planet, the Alps, the Himalayas, Alaska, is essentially a drop in the bucket next to those two, less than 1% combined.
If all of Greenland melted, global sea level would rise by roughly 7 meters. West Antarctica alone would add about 5 more meters. And East Antarctica, the single most massive ice sheet on the planet, would contribute a staggering 53 meters on its own. Add it all up, throw in mountain glaciers, and the final number lands at roughly 65 to 70 meters of global sea level rise.
To put that in perspective, that's the height of a 20-story building. That layer of water gets added to literally every coastline on Earth all at once.
Now, the detail we opened with. Logic says the closer you are to melting ice, the more sea level should rise there. In reality, it's the exact opposite. The Antarctic and Greenland ice sheets are so enormous, so heavy, that they have their own gravitational pull. Faint, but real. That gravity literally tugs ocean water toward it like a magnet, slightly raising sea level near the ice sheet right now, today. Once the ice melts, that gravitational pull disappears. The water the ice was holding close to itself spreads out across the entire planet. As a result, sea level right off the coasts of Antarctica and Greenland actually drops, sometimes tens of meters below where it sits today.
Meanwhile, in places as far as possible from the former ice sheets, which happens to be exactly where most of the world's major cities are, the water rises even higher than the average forecast suggests. This is called the sea level fingerprint of melting ice. Every ice sheet on the planet signs the ocean with its own unique gravitational signature. And when that signature disappears, water redistributes unevenly across the entire globe. The result? New York, London, Shanghai, Mumbai, all of Florida, and the Netherlands end up completely underwater. Meanwhile, some coastal settlements right along Antarctica's own shoreline, paradoxically, end up with a bit more land than they have today. February 2002. The Larsen B ice shelf, off the coast of Antarctica. Over 10,000 years old. Roughly the size of the U.S. state of Rhode Island.
In 35 days, it was gone. Completely. Satellites captured a massive slab of ice, standing for thousands of years, literally shattering into thousands of fragments, live, in real time on orbital cameras, faster than scientists could even react. Nobody expected that speed. Researchers assumed something like this would take decades, if not centuries. What made a 10,000-year-old ice shelf vanish in a single month? And what does that tell us about how fast this planet can actually change? I'll get to it in a minute. The explanation behind Larsen B turned out to be alarmingly simple. That summer, an abnormal amount of meltwater pooled on the surface of the ice shelf, thousands of small blue lakes. The water seeped into cracks and started prying the ice apart from the inside, like a hydraulic press. At some point, the entire structure gave way all at once, like a house of cards, instead of gradually, layer by layer. Scientists call this hydrofracturing, and it's now used as a model for just how fast ice can collapse once a certain threshold is crossed. And this isn't an isolated case. Greenland today loses an average of about 270 billion tons of ice per year. Antarctica loses another roughly 150 billion tons. Those aren't abstract numbers. That's a mass equivalent to millions of Olympic swimming pools of water draining into the ocean every single year. And the process feeds itself. White ice reflects sunlight back into space. When the ice melts, it exposes dark rock or dark ocean water underneath. And dark surfaces do the opposite, absorbing heat instead. That spot on the planet starts warming even faster. It's called the ice albedo feedback loop, and it's exactly why scientists are less and less confident this process will stay linear and predictable. That's exactly why the Larsen B story matters so much. It proved ice doesn't have to melt slowly and predictably. Sometimes it just breaks. All of it, all at once. Now let's put it all together and look at the final map. Florida disappears almost entirely. Just a small chain of highlands survives. The Netherlands, a huge portion of Bangladesh, and the Nile Delta in Egypt, Cairo included, all end up underwater. London, New York, Shanghai, Mumbai, and Venice, which is barely holding on today anyway, all go under, permanently. But new bodies of water appear too, in places that have never had them. Parts of Australia's interior lowlands turn into a massive inland sea. The Amazon basin in South America partially floods, creating an archipelago of islands where solid jungle stands today. The West Siberian Plain in Russia, one of the flattest regions on Earth, also partially disappears underwater. Meanwhile, high-altitude and inland regions, Central Asia, the interior of North America, large parts of Africa, barely change at all. Humanity would essentially have to resettle, pushing deeper into continents and higher into the mountains. And of course, it's not just land that changes. Under this scenario, the planet's overall climate becomes significantly warmer, ocean currents shift, and today's familiar climate zones migrate hundreds, even thousands of kilometers closer to the poles. A world without ice isn't just a bit more water. It's a completely redrawn map of the planet. Some regions gone forever, others born in places that never had land before. The bad news is, Larsen B reminded us that ice doesn't always ask permission before it breaks faster than we expect. If this video changed how you look at the world map, hit like. It's the best support you can give this channel. Drop a comment. What surprised you the most? The gravity paradox? The Larsen B story? Or which cities end up underwater? And if you want a dedicated video on what Earth looked like during the last ice age, let me know. We'll dig into it. See you in the next video.